I'd like to start off this lesson by talking about some basic electrical concepts. We know electronics will be part of your everyday job. A matter of fact, as a technician, 90% of the problems you encounter will be electrical. The remaining 10% is going to be split between mechanical, installation, and sometimes even customer understanding problems. But you really need to understand basic electrical and electrical concepts going forward in this trade. So what is electricity? Well, it's a fundamental element of nature. Electricity starts with an atom consisting of an electron and a proton. The electrons jump from atom to atom. These movements of electrons creates current. With the use of a proper conductor, this current will move in a controlled manner and become usable. Electronics is the study of the movement through electricity, through wires, switches, and loads. Conductors are substances like wire, metal, earth, and water where electricity can easily pass. One of the things you have to remember from a safety perspective is that the human body is a great conductor of electricity. Insulators are substances such as rubber, cloth, dry wood, and glass that resist the flow of electricity. Insulators are found in the top of telephone poles and around wires. Insulators are there for safety and to isolate electrical wires. Most of the insulation we deal with in HVAC will be rubber or plastic. Electricity is produced by one of four methods. Friction creates static electricity. Chemically is how electricity is produced in a battery. Magnetism is how electricity is produced in a power plant. And mechanically is how electricity is produced in a thermocouple. You could also say by heat. An electromagnetic force is one that is created by a magnet spinning inside a wire. The current that is generated by the spinning magnet is sent out over the wires to do the work. This is power, voltage, and amperage. Voltage is the potential for electricity to do work. Voltage is measured in volts on a voltmeter. Current is the movement of electrons. Current is measured and recorded in amps. Basically, it's how fast the electrons are moving by a certain point. Resistance is the force that opposes electrical flow. If there were to be no resistance, then the current would run uncontrolled, and that would become what is known as a short circuit. Resistance is measured on an ohm meter in ohms. Watts are the measurement of power. 1 watt equals 1 amp of current flowing with a pressure or potential of 1 volt. Watts are what's used by the power company to bill customers. We have two types of current. We have alternating current and direct current. Direct current is known as DC. Direct current is what's produced by batteries. It's what's used in automotive. Direct current is used inside high-tech electrical devices. Direct current is also used on a lot of higher-end, i.e. more expensive, control devices. We're going to deal with direct current when we talk about direct digital control. Alternating current, known as AC, is what's available from the power company. Alternating current has a wave pattern to the voltage levels that vary between positive and negative. In the United States, this change between positive and negative happens 60 times per second. If you take a look at the red line on this chart, this is one complete cycle of alternating current. We start off at 0. In this case, we go to a positive 170 volts in the quarter cycle, drop back down to 0, then go to a negative 170 volts, and complete the cycle in 60 times per second. In other words, 60 of these cycles occur per second. Our voltage that we would see with this is 340 volts. Okay, your negative max and your positive max in this case. Frequency is the measurement of the AC voltage as it shifts from a positive to a negative. Frequency is measured in hertz. This is usually based on the number of times per second. In the United States, as I said, our current is 60 hertz. In Europe, that's 50 hertz. Knowing that European number is sort of important because a lot of our equipment is manufactured overseas. Occasionally, you might come across a piece of equipment that was shipped in the wrong box or with the wrong shipment. Always check the frequency of anything you're installing. Now, there's several parts of a circuit, but let's start with line voltage. Line voltage is the power coming in from the power company. Line voltage is a high voltage and in most cases can cause you serious harm, if not death. Line voltage is available from the wall plugs in your house. Control voltages are lower voltages. Control voltage in the heating air conditioning industry is 24 volts alternating current, VAC. Control voltage is designed to be easier and safer to handle. Let's put it this way. You have a thermostat hanging on the wall in your house. It has cracks and little areas for air to pass through it behind it. You take that thermostat, you put 120 volts into it. Someone's going to stick a finger, knife, or something into it. It happens all the time. You take control voltage at 24 volts, put it into that thermostat. Which is going to be safer, the 120 or the 24? 24. So a circuit is a complete electrical circuit. In other words, it's full path for electricity to flow. A circuit has to consist of 4 parts. It has to have a source, a switch, a path, and a load. A source for a circuit can be a battery, it can be a transformer, it can be a wall outlet, it could be a power line, it could be a breaker panel, and it could be a power plant. A path for an electrical circuit can be a wire, a circuit board, or a piece of grounding strap. In other words, a path has a very low resistance, and this allows electrons to move freely and without heat. A path with a high resistance will heat up. A switch is a valve or a gate that stops the free flow of electrons from flowing. It does this by opening the path. Now we can add 2 more terms to this conversation. Open is a gap or opening in the path of the circuit that stops the flow of electrons. Closed is a path that is complete, that allows the flow of electrons. If you're trying to equate this with a water valve, it is exactly opposite from a water valve. An open valve allows the flow of water. In electronics, an open switch does not allow the flow of electrons. In a water valve, a closed valve cuts off the flow of water. A closed switch allows the flow of electrons. Exactly opposite. A load is the portion of electrical circuit that actually does the work. This can be a light bulb. The work is creating heat and light. It could be a motor. The work is turning the shaft. It could be a heat strip. The work is putting off heat. It could be a coil. The work is creating a magnetic field. In order to properly troubleshoot and design circuits, we have to have a way of putting them on paper. A picture of a circuit is called a schematic diagram. These diagrams are composed of symbols that represent each part of a circuit. These symbols are called schematic symbols. A simple circuit might have a L1 and a neutral. That's basically your source. It's going to have a switch labeled S1 in this diagram, and it's going to have something that does the work. Could be a light bulb. In this case, it's labeled B1. So we have a few schematics of a switch here. There's different types. Single pole, single throw has one opening and one direction it can go. Single pole, double throw has one connection for source, and it has 2 possible positions. The pole is the connection to source, and the throw is the right side here, which is either open or closed. Source on a schematic can be labeled L1, L2, N, or anything else. It is usually at one side of the schematic and everything else works from there. Loads are shown by either an actual schematic symbol for the load or by a circle with a letter and a key. Loads are the portion of the circuit that does the work. More complex circuit is here. In this case, source is L1 and N. We have switches, and we have some other symbols that we're going to talk about as we go on further. C2 on the top row is a normally open contact. C2 right below it is a normally closed contact. In the center, we have a transformer labeled 24 volts on the secondary side. And then we have a thermostat labeled T1, and we have a couple pressure switches, PS1 and PS2, and we have a coil labeled C1. When you're working in the shop or in the field, make sure everything you're working on is unplugged and turned off. Try to use black wires for line voltage sources. Use white wires for line voltage neutrals. Use red wire for control voltage source, and use orange wire for control voltage common. If you're working in the shop in the school, your instructor needs to check all circuits before you power it up. If you're working in the field and you're unsure, ask someone else to check it as well. For those of you in the shop, we're going to build a basic circuit. And please make sure you ask if you need any help or have any questions. Your first circuit is a normally open switch, SS, that's your service switch. SW1 is a second switch. B1 is a light bulb, and N is neutral.